Hey yo, what's up my little coders? In this tutorial, I'm going to teach you about regular expressions in Java. After watching this video, you will learn about the syntax of the regular expressions. You will find out what are the pattern and matcher classes and how to use them. I will show you different use cases of regular expressions in Java. For example, how to check whether a string matches a regular expression or not, what are the groups in regular expressions and how you can extract them, and also how to replace something within a string if it matches the regular expression pattern. All of this will give you a solid foundation of regular expressions in Java. Alright, my little coders, let's get started. So, first of all, what are the regular expressions? A regular expression, or it's also called regex, is a special sequence of characters that helps you to match or find other strings or sets of strings using a specialized syntax held in a pattern. They can be used to search, edit, or manipulate text and data. Regular expressions are very widely used in software development, and every developer should have a good understanding of them and know how to use them. Okay, my little coders, so first of all, in order to write the regular expressions in Java, you need to learn the regular expression syntax for that. On the right side, I have captured the main things for the regex syntax. It's not the full syntax, and probably just like 20% from it, but it's the main 20%. You can write the regular expression, let's say the one which would search for a particular pattern in a string. You can do it in multiple ways, just by playing around with the regex syntax. However, with what you can see on the right side, I personally believe that it should be enough to write a solid 95% of regular expressions which you would ever need to write. So it should be more than enough for you, at least for now. Alright, you can see the pattern and matcher classes here. They're coming from the Java util library. A pattern class is basically a compiled representation of a regular expression. It has a static compile method, which accepts a regular expression as its first argument. And the matcher class is the engine that interprets the pattern and performs match operations against an input string. Imagine that we have an input string and we want to validate whether it matches our greeting pattern. Let's say our greeting pattern is just the word hello. So when the input string is equal to word hello, we want to return true, otherwise we would return false. Now let's say that we get the input string and it's equal to the hello. Let's print the results now. Let me just simply write matcher.find to see whether we found the match or not, and we can just print it after that. So if I run this code now, you can see that there is a match. So the input string matches the pattern. If, for example, I would change a bit the input string, and I don't know, put 1 here, then if I would run it, I would get a false because now the input string doesn't match the pattern. So this is like, very simple example of how the regex actually works. Now let's think about something a bit more complicated. Imagine that you work in the secret intelligence service, like MI6 in the UK, and imagine that we have a website where our secret agents submit some secret forms. In one of the forms, the secret agent needs to provide which agent he or she is, like, I don't know, agent 007 as an example. How can we validate that the agent submitted the information in the right format? Imagine that the rules are the following. You have a word agent, then a space, and then after the space you have any 3 digits. How can we write our pattern for that so that, like, the pattern would not accept only, exactly agent 007, which in this case would be true, right? But if, for example, this agent would be 008, how to write, the pattern, which in this case would return true as well, because now it returns false. How we can do that? Let's see here what is the digit in the regex syntax. The digit in the regex syntax is the /d, or it also can be replaced by a range of the digits from 0 to 9 in the square brackets. Okay, we have 3 digits. If I would write something like that, in fact we need to have the double slash in Java. because this is just like some compilation rules of Java. So this /d would mean that we have agent like here, and then we have a digit, which can be any digit. However, it matches only one digit. So if you want to match all three digits, we would need to put 3/d here. Now, if I would run it, you can see that I get true, and this regex matches the input string. So, I can just replay these three digits with any digits, and it would return me true. And write something like that, I get true. But, imagine if the input string would have, let's say, I don't know, 300 digits, and we would, want to match it. In this case, I don't think that writing a /d for 300 times would be, the best idea. In this case, we can use something else. We can just specify the exact number of something what we expect after that. So imagine we wrote one digit here, and now we can say after that straight away how many times we want it to appear in order to be valid. If I write 3 here, it would mean that, okay, I have agent, then space, and then I expect a 3 digits after that, exactly 3. So if I run it, I get true, but if, for example, I would have 2 digits, but not exactly 3, I would get a false. Also, if you want 3 or more, you can, for example, put comma, which means that you start with 3 and then you go to infinity, but you want to have at least 3 digits. So here, it still would return as false, but if, for example, I do 0007, I get true. Or else you can specify, let's say I want exactly 3 or 4 digits, which would mean that here I should get true, because it's either 3 or 4. With 3 as well, I should get true. But if, for example, I don't know, I would have 5 digits, I also get true, and I'll explain you why I get true just in a second. But with 2, we get false. So this was one of the ways to do that. If you want to practice a bit, there is one very cool website. It's called Regex 101. Basically, you don't need to every time write your regex and compile your code. You can just use this website, Regex 101. Make sure you specify Java here. You can just write your regex here, and you can quickly validate your input strings. And this website is super useful website in writing the regular expressions. Imagine if I would add something here. Now it highlights that the input string matches our regex, and basically you can quickly create many examples, and one line will be like a separate string. Then if I do a third example with 2 zeros, you can see that now it doesn't highlight our input string, and now it means that we don't have a match. So this website is very useful for testing in order to quickly validate your regex whether it's correct or not. Okay, I told you that if I write extra 0 here, remember, in this case, we've been getting true. And you may be wondering, how come, we specified that we want exactly to have 3 or 4 characters? How come it returns true in this case? Because we have 6 digits. Why it's true? The thing is, you can see an example here, with the 6 digits, that it actually matches not the whole 6 digits, but it says that, this part is, is valid. It has from 3 to 4 characters, but the regular expression doesn't care about what happens after that. So it means that if, for example, I would put some extra stuff here, regex doesn't care because it just looks like whether this pattern is inside the string or not, but it doesn't care about what is on the left side, what is on the right side. Just if it can find the match, it means that, it's valid. But if you don't want to have these edge cases, if you want to, check that the whole string from the beginning until the end matches the exact regular expression, you can just simply add some extra stuff. In the regex, in order to say that we have a beginning of our string, we can use this character. It would specify that if we put it here in the beginning, it would specify that we want to start our string with everything what goes after this character, so with our pattern. And now you can see that, this example is not valid anymore. But if we, for example, would add something like this, now we have a match. But at the same time, if I put some rubbish here, you can also see that it still matches the regular expression. And then in this case, if you don't want this situation to be a match, you can just simply specify the end of the line with this character. And now you can see that now we only have one match. And I could add the extra digit, it still would be a match because 3 or 4 digits. But if I add, let's say, the fifth one, it's not the match anymore because we added some extra constraints at the beginning and the end of the string. Now, as I told you, you can write the same regular expressions in different ways. For example, this /d, which means a digit, it also can be replaced by, let's say, with something like this, which means that, we have one character, and this character is in the range from 0 to 9. So every digit, which is from 0 to 9, is valid. But, for example, if I would do something like this, let's say 009, and at the same time I would do 007, and now I would specify that this digit is from the range from 0 to 8 instead, then now you can see that this is still a match, but 0009 is not because 9 is not in the range, right? So this is just another way how you can write the regex. But okay, let's put it back because I prefer the /d a bit more, to be fair. Now let's consider another situation. Imagine that the secret agent, can write, let's say, agent 007 with the lowercase a, but sometimes it would also like to write the uppercase A, and we want it to be a match as well in this case. How we can expand our regex in this situation? For example, one of the ways is to replace this A with dot. And dot in regular expression, you can see that dot is basically any single character, so it would match anything. It can be a lowercase a, uppercase a, but at the same time it can be anything, exclamation mark, and still match. Okay, this is maybe not the best way to handle this situation, but just wanted to give you another example of the regex syntax. Okay, what if we want to exactly match the lowercase a or uppercase a? In this case, you can open your square brackets and basically you can specify what exact characters will make a match for the first character, and you can just simply write here lowercase a and uppercase a, meaning that the first character either starts with lowercase a or uppercase a. And now you can see that both of these are matches. But if, for example, okay, let me remove this stuff. If, for example, we will start with B, it would not be a match. But you might be wondering, what if we have 007, who is our agent, but our agent can be AA007. So imagine if it would be something like this. Obviously it's a joke right now, but just to give you an example of how the regular expression syntax works. What if we want to handle this situation as well? How can we do that? One of the ways to do that is to use the or, lowercase a, uppercase a, or double A, and I can try to replace the squared brackets with the normal ones. And in this case, you can see that all three would be a match now. And you can see that the things have been highlighted as green, about which I will talk very shortly as well, what it all means. Okay, I think it's enough for the introduction to the regex syntax. I think I almost covered everything. Different letters, the ranges, or /t. Yeah, any word can be simply, let's say, replaced with just /w, but /w it's only one character basically, right? But you can also specify the amount of characters which you expect. For example, a star means that you have 0 or more occurrences, meaning that this can be any word character, but then like if I put a star here, it would mean that I can have as many characters as I want, and it can be any word character before I find out my 3 or 4 digits. And at the same time, if you don't want to match 0 or more, you can, for example, match 1 or more with the plus. If I replace the star with the plus, it's still the same thing, but now it should have at least one character, one word character. And also we have question mark, which matches like 0 or 1 occurrence. So 0 or 1 would not work in this case. However, if I replace this the beginning of the string matcher, you can see that, yeah, we match 0 or 1 and we have at least 1, so we match it. But if, for example, I just would have a space like here and then 007, you can see that it's also a match because question mark here again matches 0 or 1 occurrence. So I think it's pretty much the whole syntax and I covered everything. Okay, now let me cover a bit more examples of not the syntax, but of the, pattern matcher classes and what they can actually do. Okay, let me just write our modified regex here. Just let's see if it still works. So this returns false, but if I remove the extra zeros, yeah, we get true. So you can see how many situations you can handle with the regex, and it's very powerful. But always think about edge cases because there can always be a lot of edge cases. But okay, guys, let's move on. Imagine that we matched whether the string is valid or not. But let's imagine what if I would want to extract something from the string. What if I would want to extract the exact number? Because sometimes it can be 007, sometimes it would be 008. What if I want to extract this exact number and don't care about what was before that? I just want to, simply get this number. How can I do that in this case? Basically, we can use something what is called groups. So, you see here that we highlighted it in the green, right? If I do the same on our number regex, you can see that now we have the blue, which is our whole match, green, which is like the first expression in the brackets, and now we have the orange color, which is, our digits in the brackets as well. So these are basically groups, and you can extract these groups. Okay, let's remove this double A to make it a bit more simple. Okay, now you can see that we have only one group, which is highlighted in green, and it is our digits. So if I would want to extract these digits in the Java code, I can just simply do something like this. If, let's say, I have a match, because I cannot extract something if I don't have a match, otherwise, I might get an exception, an error, and, it could potentially break my code. So if I'm sure that I can extract something, if I have a match, I can just basically try to print this. If you just call matcher.group, by default, it would extract the whole match to us. But you can see here that in the green, we have the group 1. So if I would add more groups, if I would, I don't know, put this letter T as a separate group, you see that I get more groups. But right now, I have a group 1, which is like this part, the digit part, right? And I can just specify that I want to print the group 1. If I run the code now, you can see that, I am printing exactly 007. So not the whole input string, but just, the particular group from it. And this might be very useful. This is the beauty of Java Regex. But it's just part of all the beauties. Now let me show you something else as well. Imagine we would have the, the card number, like the debit or credit card number. And, it would look something like this. Imagine that this is our card number, but we don't want to display this whole card number, somewhere on our website, would say, but we would want to mask it. Let's say we want to get something like this instead. How can we achieve it with the Java Regex? And I will show you now how we can do that, because it will be super simple. So card number will be our input string, okay, if I put it here, but what will be our regex? Think about it. We want to capture the first 12 digits and all the hyphens between them, and we want to replace them. So as we have seen before, we can match the digit by /d, right? But we don't have only the digits, we have also these hyphens. So let's do it, step by step. Let's first of all match the first 4 digits. Okay, we have /d, then we put 4 for amount of digits. Okay, we match this stuff. Then we might have some hyphens, right? So I put a hyphen here. Cool. After the hyphen, you can have another 4 digits. And after that, we would have another hyphen. Let me put another hyphen. And after another hyphen, we would have another 4 digits and again a hyphen. And now you can see that, yeah, we matched everything what is before the last 4 digits. So we can put it as our regular expression. So we have our pattern ready, we have our matcher ready. How can we mask the string now? We can do it by, let's say, first of all, creating a new string. And it would be equal to simply our matcher dot replace all, or replace first, doesn't really matter. And you can just specify with what you want to replace your matcher. So if we would just simply print this masked card number, let's see what we get. Yeah, we get what we wanted. This is another feature of what you can do with the regular expressions in Java. You can replace the stuff as well. So, we covered how you can match the stuff to just validate whether the string matches a regular expression or not. And now you can also see how can we replace the stuff with the regular expression. However, let me show you one more example of what you can do with the regular expression. Imagine that our input string would look like this. 10 divided by 2, right? And imagine we have a text, right? But we want to convert this text to, actual expression and actually divide the digit and make our program to calculate the result. So let's write a regular expression for that. So, okay, this can be 10, but it can be any other digit. So I can just simply say that it's a /d, but we definitely want to have at least one character in this digit, but it can be, a bigger digit. So I can just write /d plus, and again, plus stands for the matches one or more occurrences. And the same logic applies for what we have after divided by. So okay, now we have a match. However, we want to extract the digits, so we can use the groups, as you have seen before. We can put it into the brackets, and we can do the same stuff here. So now we would have 2 groups, and we can just simply extract these 2 groups. So I think our regex is ready now. But just to make sure, let's just, for our safety, specify the beginning of the line and the end of the line, so that if you add some extra stuff here which doesn't match, you don't get the match. Okay, cool. Okay, we have the pattern ready, we have our input string. How can we simplify this mathematical expression and translate it to the real division? Okay, imagine that we want to simplify this stuff so that we would have also a string. Imagine if you want to convert this string to the following string, to just something like this. So 10 divided by 2. How can we do that? Okay, we have our groups, right? Group 1 for the first digit, group 2 for the second digit. And in order to get these groups from the string, you can write something like $1. Now you're getting the first group, then you can write whatever you want. But if you want to get the second group, you can also write and 2. And basically this would extract the group when you do it inside the replace first. So if I would print this stuff right now, let's see what we get. you can see that we simplified our expression right now. But if I would say want to not simplify, but actually, calculate what would be the result, how can I do that, guys? Let me show you. You can just simply do integer dot value of, and you can just simply take our matcher, our group. Let's say this one will be the group 1, right? And basically divide it by group 2, integer value of group 2, and we do a division. And if I would print this division, let's see what I get. Yeah, you can see that, okay, we started with our original string, then divided by 2, then we, simplified it, and then we actually calculated the proper result. And, guys, again, we started with this input string. So as you can see, you can really do a lot of things with the regular expressions. And, as I told you, they're super useful, and, you need to make sure you learn them properly because regular expressions are very important. If you liked what I have showed to you, and if you think that it was useful to you, and if you learned something from it, please, guys, give me a like and subscribe. And yeah, guys, good luck with learning the regex. Thank you, and see you later, guys. Good luck.